All right, as I try to classify quadrilateral EFGH, I'm looking at my notes here. Keep this thing out in front of you as you work. So I know right away that this is a quadrilateral. Because it has 4 vertices. So it has 4 points, 4 vertices. It's a quadrilateral. All right, next, I'm going to figure out, is this thing a trapezoid or a parallelogram or neither? I'm going to use the slopes to determine that. So the slope of EF, if I look right here, it's going up 0. That's a flat line, so the slope is 0. Slope of FG, well, it goes up 5 and over 0, and that is an undefined slope. All right, so this is the slope of FG. It's undefined. This is the slope of EF. Now the slope of GH, again, that's a 0 slope because it's a flat line with no slope. And then EH, again, that's up 5 and over 0. That's an undefined slope. All right, so I have 2 sets of same slope. So if I look right here, parallelogram, 2 equal slopes times 2. So these are the same, these are the same. I know it's a parallelogram. Parallelogram. And why is that? Because I have opposite sides parallel, or same slope. All right, so it's still this, but now I'm refining it to this. And I'm going to see if I can take it even farther now to one of these special ones. All right, so what I'm going to do is see if I have 90-degree angles. So do I have 90-degree angles? Typically, when we're looking for perpendicular lines here, I'd look for something like -4/1 for one of the slopes and 4/1 for the other slope. And then when I multiply those, I get -4/4, which is -1. That'd be what I'm looking for. I don't have that in this case, but what I do have is a 0 and an undefined slope. And we just have to know that these two right here are perpendicular. So EF and FG are perpendicular, so that gives us a 90-degree angle. And I know that in any parallelogram, 2 consecutive angles are supplementary, so 90 plus 90 is 180. And then these two are congruent, those are congruent, so I know I've got 90-degree angles all the way around. So I know this is a rectangle. And the reason why is I have perpendicular lines from the slopes. And when you do this on a test or a quiz, you've got to show me that you know those are perpendicular because of their slopes. Next, I'm going to see, is this thing a rhombus? So is it a rhombus? Do I have the same distance here and here? Well, we've kind of lucked out with this one. We don't have to use distance formula. So I'll write it anyways. Distance formula would be square root of x2 minus x1 squared plus y2 minus y1 squared. I'll go ahead and do it. I'll do it for EF. So the x here is 1. The x there is 6, so it would be 1 minus 6 squared. And then the y here is 5. The y here is 5, so 5 minus 5 squared. So I end up with the square root of -5 squared plus 0 squared. So that's square root of 25, which is 5. And then the distance here, GH. So this, that first one, sorry, was EF. And now GH, I basically get the same thing. GF. Let's do GF because I'm looking at this one and this one. Are they congruent? So the x values are the same, so that x is going to give me a 0. And then my y's, I've got a 10 and a 5. So 10 minus 5 squared. So that's the square root of 25, which is 5. All right, so it is a rhombus because EF is congruent to FG. So last, is it a square? Now remember, for a square, we don't have to do any additional tests because if this is true and this is true, then it's a square. So it's a square because it's a rectangle and a rhombus. So this is the most specific classification we can get for this quadrilateral. It is a square. So we'll stop right there.